Alrighty, now let's talk about graphing absolute value inequalities. First, I want to go over the domain and range when we've got absolute value inequalities. As a reminder, any type of inequality, we're going to have some shading going on here. With the domain, just like if it wasn't an inequality, it's still going to be negative infinity to infinity, or all real numbers. Then the range depends on what is being shaded. If the shading is in between the two lines, your range is going to go from a number to infinity or infinity to a number if it was reflected. So looking at this example, the lowest this graph gets is at a y value of 0. Line is solid, so I can use a bracket because 0 is included in my answer. If it was a dashed line, we would use a parentheses here. Then the shading is everything above that, so from that y value of 0, I'm including everything greater than that, so it's going towards positive infinity. In our second example, the domain is still negative infinity to infinity, or all real numbers, but this time the shading is outside of those lines. If the shading is not in between the two lines that make up your absolute value function, the range is also going to be negative infinity to infinity, because the shading is going to take up every single y value. Even though it's going down, that shading keeps going with those lines, so it's going towards negative infinity, and then it's also going towards positive infinity because we're shading everything above these lines as well. So if your shading is outside of your function, not in between the two lines, the range will be negative infinity to infinity, or all real numbers. Now let's practice actually graphing these ourselves. First, we need to list out our transformations. Then we'll check and see if we need a dashed line or a solid line and where we're going to shade. In number 1, y is greater than negative 2 times the absolute value of x plus 4. This plus 4 on the outside tells me I'm going to go up 4 from the origin to find my new vertex. There's nothing inside the absolute value besides the x, so there's no left or right shift. The negative out front tells me we're going to reflect over the x-axis. And the 2 tells me we're going to stretch by 2. So our graph is going to get a little bit skinnier and taller. It's stretching. So I'm going to plot my new vertex. From the origin, I go up 4. Then that stretch by 2 tells me I have a slope of either 2 or negative 2, depending on which side I'm dealing with. And the reflection tells me it's going to be upside down, so it should be an upside down V. That slope of 2 means I can go down 2 and to the right 1. I can also go down 2 and to the left 1 from the vertex. I'm just going to plot a few more points to make sure I know exactly where this is going. Now I need to look at my sign. This is strictly greater than a dashed line. And then for the shading, I need everything greater than my line. So this is going to be outside of my function. Our domain, negative infinity to infinity. Because the shading is outside of my function, not in between the two lines, the range is also negative infinity to infinity. In number 2, we have y is less than or equal to 4/3 times the absolute value of x plus 3. That plus 3 on the inside says to shift to the left by 3. The 4/3, that's greater than 1. Even though it's a fraction, it's greater than 1, so it is a stretch by 4/3. And that's all that we have for our transformations. No reflections, we're not moving up or down. So our first point, the vertex, is going to the left by 3, so we're at negative 3, 0. From there I can go up 4, 1, 2, 3, 4, and to the right 3. I can also go up 4 and to the left 1, 2, 3. This has a a less than or equal to, so it's going to have solid lines. And then the less than part tells me everything below my graph, so I'm shading outside of this graph. So once again, our domain is all real numbers and our range is all real numbers, or negative infinity to infinity for both. In number 3, y is greater than or equal to negative absolute value of x minus 2 plus 2. The x minus 2 on the inside says go to the right by 2 units. The plus 2 on the outside tells me to go up by 2 units. And the negative out front tells me we're going to reflect over the x-axis. So from the origin, I need to go to the right 2 and up 2 to find my new vertex. And then I'm reflecting. There's no other number directly outside of my absolute value, so the slope's going to be 1 and negative 1. So I can go down 1 and to the right 1 each time. I can also go down 1 and to the left 1 each time. It is greater than or equal to, so we have solid lines. And the greater than part tells me we're going outside of our graph here. If it was less than, we would be in between the lines and our range would be from negative infinity to 2. But because it's outside here, it's outside of those 2 lines, it's from negative infinity to infinity, aka all real numbers. Just to give you a quick example, like we had on that first slide we were looking at, let's say our graph looked like this, and suppose that we were shading in between the 2 lines. Our domain, still all real numbers, but this time our range, because the shading is in between the 2 lines, would be from 0, it gets a bracket because it's solid lines. If it was dashed lines, this would be parentheses. And then it's going upwards towards infinity.